And one of the articles that I'm referencing was submitted to the next one coming out, so you may be able to see that. So we're definitely going to talk about some patterns that Chris went over in these. And so what I'm talking about today are antenna tapas. And you're sitting there going, what the heck is he talking about? Well, probably most everybody's been to a Greek restaurant or a Mediterranean restaurant, and they have, or Spanish, they have these tapas, these small plates, little small things. So we're going to try to talk about little small antennas that you could build, you could actually put in your backyard. So I'm going to start with two of the smallest that I have. Everything in here that I'm going to show you, I have personally either been there, built it, used it. So we're going to talk about the first two smallest antennas that I've ever dealt with in my ham career. This is actually was a guy that I knew, Buzz Reeves, K2GL. He's a silent key. And that is a full-size 3-element 80-meter beam on a 200-foot tower. That 200-foot tower is about, what is Roan 80, 4 feet on a face? It is a big tower. He had the professional riggers come in to put that up. And then when they weren't available, when the first one blew down, he had a 4-element 80 at one point, but it blew down in a windstorm. So he had the helicopter company come to put the 3-element up on the top of the tower. Killer antenna, but you're never going to build that. The other is Jim Lawson's old Big Bertha. And that was a 120-foot freestanding rotating tower built out of steel. The base was about 8-inch diameter, and it necked down. And you welded it all together and put it up with a crane, and Jim could aim his stacks pretty much anywhere he wanted. He's got a 6-meter in the middle, a 40-meter in there, and 10-meter, 15-meter, 20-meter. And I was telling John earlier, I forget what band I was on. It was probably 20, and I was trying to talk to somebody in California, and I was just getting stomped on. And I hear this voice, and he's like, "Hey, Doug, you want me to blow a hole?" And it was Jim, W2PV. And I said, "Oh, sure, Jim." And he just talked for about 3-4 minutes. When he unkeyed, the band was quiet. He blew a hole, and I continued to talk to my friend. We're not gonna build these, but what we're going to talk about today are some cheap VHF Yagis, some HF antennas you can build, some experience we had with some Cushcraft tri-banders out at Field Day. You may get some of these that somebody says, "Do you want this? Just take it down." And it doesn't work. What do you do? One of my favorites is 6-meter antennas. I love 6 meters, and we've been experimenting with myself, some friends of mine, and I encourage everybody, you should have an Elmer and you should be an Elmer. And one of my Elmers is, we're experimenting with 6-meter antennas to use during the VHF contest. And so we're going to talk about that a little bit. And also the big one that Chris touched on is you're sending a signal from your antenna. Is that going to a place that somebody's going to hear you? Or are you sending it out into outer space that only the Romulans are going to hear you? So, and I loved Chris's little balloon here. I forgot my prop, which is one of those, now with the new LED and everything, but the old mag lights with the halogen bulb. And you can take your flashlight and shine it against the wall, and you get this little ring. And then you take the head of it and twist it, and it changes. When I do that, do I get any more power out of the battery into the light bulb? No. But the pattern changes. So how did it get brighter? As I twist it, I'm redirecting the energy. That's what these sample Yagis, I'll grab a 450, 440. When I add all of these elements, as Chris pointed out, this dipole is radiating out, or if it's sideband, in this direction. I put a reflector, and it's like putting a mirror. These parasitic elements, these directors, are like eyeglasses. They're focusing the beam such that, as opposed to if it's a dipole, it's this big round pattern. And as I put these reflectors, these directors, I've focused it in just like a mag light. And so the question is, if I'm trying to illuminate Dean behind the camera here, and I have my mag light aimed over at Tristan on the other camera, he's going to be in the dark. If I'm trying to work a station on FT8 from Colorado here in New York, and I have such a narrow signal that the signal's not bouncing off the ionosphere or ground waving, I can have all the gain in the world. Oh, do you have a mag light? Does that, yeah, except I'm staring into the sun here. So okay, so we've got this, you can see this is my dipole on the wall, and there's my Yagi. I don't have any more light coming out of this thing. And there's the button. Thank you. These days, there's very few people that have focusable flashlights. They're all these LED, super high intensity, and they're just optimized. So we're going to talk about that a little bit. So one of the things that I wanted to get into is cheap Yagis. There is a gentleman that has, and thank you to Chris for bringing one of these, that is, his call sign is WA5VJB. Name is Kent Britton. He runs this little company out of his basement called Kent Electronics. And he's very, very active in the VHF, UHF weak signal, microwave areas. And he decided one day he was going to publish how can I build a Yagi and make it cheap? And this is an actual, real Kent Britton Bitey Bite cheap Yagi. It's a piece of wood, some Chris used brass elements, it looks like. I think he also talks about copper. So very simple driven element, but that's part of the magic of these. He came up with an elegant but simple driven element. And you can go to his webpage, wa5vjb.com. And I've talked to him. He's a good friend. And he said, yep, just give me credit for it. Go to his webpage. You can go to the cheap Yagi pointer there where I've got the purple arrow. And you'll get an article. But also pay attention to, you can see there is the log periodics. It's a little hard to see on the other screen. Yagis, patches, ultra wideband, and wheels. Most of those are for higher frequencies, but if you are looking for a small 432 antenna, he actually makes these Yagis that he prints them as traces on printed circuit board. And they work very well as dish feeds, little experimental antennas. But we're going to go into the cheap Yagis, and it'll bring up this article that you can see. Is anybody here on 440 and you don't have a Yagi, a decent amount of, would you like a $5 antenna? Now with our current inflation, this may be a $10 antenna, but when Kent wrote this, he says, here's a $5 antenna. It's easy, cheap to build. You're not going to be the loudest guy in the band, but you'll make contacts. If you've ever heard somebody on the repeater say, well, it sounds, you're weak, Jeff. Are you using a wet noodle for an antenna? I actually did try that once. I was cooking spaghetti. I put the noodle inside in my BNC connector, and I was able to key up the repeater. There was enough moisture. I recommend cooking your pasta al dente, otherwise the noodle just folds over, and you get horizontal polarization, and I wanted vertical to get into the repeater. But I did make a QSO on the wet noodle. I was not strong. But here you can go. Now, on these things, I showed the charts. I'm going to use the 432 because it's a little bigger. He's got a very simple driven element. That is much more simple. This is a Cushcraft. And this is just a hairpin match or half of a folded dipole. Whereas on this Cushcraft, they went with a gamma match. And you'll see this very common on HF antennas. It's easier to implement. If you go to some others, and I didn't bring one because they're frankly too big, there'll be two of these with multiple straps that they call instead of a gamma match, they call it a T match. But that's the more efficient. But Kent went with a very simple, and what he did is, you notice has the shape which matches the impedance the best we can for just putting a piece of coax. So if you're interested in one of these, come up and look at Chris's. He did a really nice job of soldering foam dielectric coax, which usually when I do it, I just get this big melted blob of stuff. So it's a nice job. And you can build a Yagi. You can pick how many elements you want, and he gives you the lengths and the spacings. They do change depending on what you're putting on here. Another little trick on these is this Yagi. If I built two identical number of elements, this one is 6 elements and this is 6 elements, but you'll notice the spacings aren't the same. The element lengths aren't the same. And that can be if you're different construction methods of the exact same frequency of antenna. There is a bit of magic into how you anchor your element to your boom. In this case, it's a non-conductive boom. And if you want this all weather, throw some varnish on it. This is a non-conductive. This is electrically connected and conductive to the boom, and the elements are on top of the boom. There are designs that the element goes through the boom and are electrically arc welded or bonded, and there's designs where they actually have insulating, we call them shoulder washers, and there's a little, usually stainless steel pressure washer that only goes one way, keeper washers. The element will be different lengths and potentially different spacings between based upon how you do this. Why is it different? What Chris was talking about of what is the voltage peaks and nodes, and what is the effect of this material on the length of the element. So it changes this bottle. So just pay attention to that, and if somebody does give you, and we typically give them away at RMHAM when a silent key donates just an end-of-life antenna, and we'll put it out there and free. And you get this thing and say, oh, I can rebuild that. Just pay attention to that and look through your books and find a design that's there. So cheap Yagi, you can get something. You can use it on the repeater. You can use it for some single sideband. Just pay attention to those lengths. There was something else that Chris mentioned that I was going to mention. Oh, so he talked about an isotropic. Is it an isotropic or an isotropic? You say isotropic, Chris says isotropic. You say tomato, I say tomato. This is a Tapas talk, so we got to talk about tomatoes and things. And we will talk about tomatoes in just a little bit, seriously. So I've got an isotropic dBi. I've got a dipole measured in dBd, and we all said, how much gain does a dipole have? If we're advertising, buy Doug's dipole, it has how much gain? What would the answer be? dBi. Exactly, correct. A dipole has 2.15 dB of gain over a theoretical isotropic radiator that we can't build, but they can calculate it. This is kind of like the Oppenheimer guys and doing the bomb. They had to calculate all this. This is Einsteinian. How much gain does my dipole have in dBd? 0 dBd. So the dipole has no gain with reference to itself. How much gain does Doug have with reference to myself? I'm me. And you should be thankful for that, because I am the maximum dosage of Doug permissible by law. And you other Dougs out there know. So I have a dipole, and in theory, if I optimize everything and I add one more reflector or one more dipole in a collinear array that Chris was talking about, I could in theory get 3 dB of gain because I doubled my antenna. But what if I put these things right on top of each other? Am I going to get 3 dB of gain? No. If I double the size, the aperture of the antenna, the general rule of thumb, I can get 3 dB of gain. But you have to do everything right, otherwise you're going to get 2, 1.5, or really not much if you don't do this correctly. So if I take one Yagi and I add another identical Yagi, I can, in theory, and I optimally space, I'll get 3 dB of gain. Now, in this example, if these were the same, would I really be getting 3 dB? Well, I have my feed pointed down and I have my feed pointed up. And when I phase these, have I put them in phase or have I done this? If you're going to stack Yagis, you got to get the spacing correct. You got to get the phase correct. If I do this, you know how much gain I have? 0. Unity. With this, I have 3 dB more than what I had. So if you're going to do that, just pay attention to your phasing lines and such. And typically, again, a rule of thumb for an optimized Yagi, optimal spaced and designed, if I double my boom length, I'm going to get 3 dB gain. So if I have, and so these are the cheap, these are the not as cheap, but this so here is a little short commercial Yagi from Directive Systems. And this one is a 12 element, what's the 12.6 dBd of gain, and what's the boom length? Boom length, 17 feet 4 inches. I believe this is the one that RMHAM has permanently installed at our Pueblo site. And we actually use 2 of these. So 17 feet to get 12 dB of gain. What happens if and so I can put 2 of these up to get 3 dB more. And if I instead go from 2 to 4 antennas, I get 3 dB more. These are on the website, by the way, Doug. There's a diminishing return. So I go from 1 antenna and I go from, let's just call it 12 dB, to 2, I get 15. I go to 4 antennas and I'm 18. And if I go to 8 antennas, 3 dB more. And if I add 8 more to 16, I get 3 dB. But if you're going to be a moon bouncer and try to not run the digital modes and run sideband CW and bounce off the moon, he's silent key now, but Dave, W5UN, had 64 Yagis on his array. And hardline phasing lines, a lot. So if you're interested in, maybe you want to try going just a little further on simplex, or you've got a rig with single sideband, I would recommend trying one of these. This is a 450. You could get an arrow antenna, which I've got a VHF here. Very simple antenna. I'm using Yagis to point to Yagis. A very simple, gamma match, the driven element, the director, the reflector. My arrows are a little loose, but you notice this reflector is longer than my director, which is the proper design. And you can go and get some, I use this for direction finding, and I'm throwing it in and out of the back of the truck all the time, so the arrows are a little bent, but it works fine. And I think I was having a chat with Willem one day about, somebody said, your elements are droopy, or one of them is a little out of, these are pretty much in line. And I said to him, well, yeah, okay, my element is 2 degrees. Break time, you're saying? Nah. Oh, well, okay. We'll take a break after this. But my element is 2 or 3 degrees off. Well, how much does it really matter? The degradation is the cosine of the angle. Now, I'm not a PhD in computer mathematics and computer science and applied mathematics. Cosine of 3 is 3 degrees. Is like 0.96 or something. There's virtually no degradation if you are a few degrees off. So now if you're 45, like Chris was pointing out, now we've maybe got a problem. Here's one more derivative. This is the 2.5 gigahertz assault antenna. It's got the high capacity magazine in it. This is actually what's called a loop Yagi. The very first ones, I believe, they built out of little cut soup cans to experiment, but this is a horizontally polarized the way it is, or it could be a vertically polarized if you twist it. But this is actually 2.4 gig Wi-Fi. And if you really wanted to get to that access point of the person that's 5 houses down the street that has an open one still, you could use this. But nice little Yagi, and I've had this around, kicking around forever, just because this was one of the first experimental Yagis I used. So let me see, I don't know. Okay, so it is currently 9:38, so shall we come back at 9:45? And those of you that are here locally, bathroom is up the hall and around. You'll need to borrow my badge, John's badge, Wayne's badge to get back in. And if you're at home, I think you know where the bathroom is. So donuts, coffee, we'll see you at 9:45. And there's my water. And we really don't let people know how much capability we have. Yeah. Yeah. We're on? Welcome back. And I apologize, I cheated you apparently out of 2 minutes of break. Mark tells me we usually do 10 minutes, but so sorry about that. So we talked a little bit about VHF directive. Now we're going to talk a little bit about omnidirectional. I just threw these in here because, again, this is something that my goal here was not to brag about how we can put up an 80-meter Yagi, which I didn't put up, but I, as I said, I visited all of these, or I knew these people. None of us are ever going to do that. But what can you do to get on the air from your backyard that's even maybe HOA covenant controlled? We talked about this little, I don't know, I call it a clover leaf, but this little antenna. With turnstile? Is that really a turnstile? Okay, I'll take your word for it. I thought turnstiles had some phasing. But I always thought a turnstile was 2 dipoles over a ground plane with phasing lines. Okay, Dean is saying yes, but whatever you want to call this, this is a horizontally polarized 432 megahertz omnidirectional antenna. This is an equivalent version at 6 meters. You could build this, or you can buy it from M Squared for $230. And if you want a little bit more gain, you can actually stack these and get some gain in by sending in all directions. So this over here is what's known as a Moxon, and Chris actually has a book written by Moxon here somewhere. Oh, here it is. HF antennas for all locations, Les Moxon, Gulf 6 X-ray Norway. So, but this is a, but what does he call it, Chris? He said a double D? A double D. That's not what I think of as a double D, but okay, there's a double D antenna or a Moxon. They're pretty cheap. There's some others by, MFJ made one, if you still see one around or at a ham fest. And I think they're a little less money. And there's some articles out there. Here it is. John Platt, friend of John's and mine, who's with Central States VHF Society, wrote a real nice paper about how to optimize it and shrink it a little bit without giving up a lot of performance to run on his rover, VHF rover, weak signal. I think he uses, John, what does John use? Is a Subaru, his rover? It's like Subaru hatchback. And he has 6 meters, 2 meters, 220, 432, all on this. And he goes to crazy places, new grids, and works the people on the VHF, UHF bands. So he wrote an article about putting the 6-meter Moxon on there. He just presented an article at last year's conference about his experiences of roving, entitled, he was doing 10 gigahertz, where he'd bring a small dish, put it on a tripod. His talk this year was soybean good, corn bad. And I was like, John, what are you talking about? And he shows the picture of, he pulled up to the place that he always does his roving from, and they had rotated the crop from soybean to corn. And all he was looking into was corn stalks from street level, and hence he said, soybean good, corn bad, for 10 gigahertz. Yes, if you're with the Corn Growing Association, we're only talking about for radio. But so you can get some omnidirectional or limited directivity, and this is a 6-meter antenna. Now, I don't know if broadcast is using channel 2 anymore for TV, but they certainly use 3. So what you could do is tell your HOA, this is a TV antenna, and they can't prohibit you from putting up a TV antenna. And all you have to do is say, yep, you see, I can see channel 2 on it. It's my TV antenna. Now, we used to have a 2 here in Denver, but I don't think they're on 2 anymore. Oh, is it low power? I think if you have an HOA neighborhood and you want to put this on your roof, you better tell them you love the programming on channel 2. So some small antennas that you can deal with.
Dave made a comment since you've had that antenna. He called it a squalo.
A squalo, because my first antenna as a young, I guess I was a general. I never had a tech. I went from novice to general. Back in the day, you had to do CW receiving and sending, and then take a theory test. And technician then was the same as general for the theory. It was just a matter, did you do 5 words a minute or 13 words a minute? So, and then extra was 20 words a minute. And you had to take a sending test again. And I was very surprised when the examiner at the FCC said, here's your written test. And I said to her, what about the sending test? And she just goes, honey, you got 4.5 minutes of perfect copy. I know you know how to send. But these guys, I need to spend my time with them. So she comped me on the sending test. But I had a horizontal halo on 2 meters. It's smaller than this. I can't, I put it up on 20 feet of mast, and I was working stations at 150 miles on 2-meter sideband with a 10-watt sideband radio on 2 meters. Now, the guys on the other end had pretty big antennas, but I worked people. And I went from that to a 2-meter Yagi, about twice the size of that, to more Yagis, and it's addictive. So, okay, I'm going to make again, this is Tapas. Are we ready for the next course? A little segue into 75 meters. This is an antenna that I saw in the ARRL handbook, not the antenna book, the handbook. And thank you, Chris, for bringing these. So this is a 2015 edition. The exact article that I saw was not explicitly called out in this one, but in the one that I have it is. What's the summary of the difference between the ARRL handbook antenna section and the ARRL antenna book? This is a little bit more theory. The antenna book is a little bit more practical. Great to have both. Available from arrl.org, and send them your money and they'll send you a wonderful set of books. And there may even be a special commemorative. I know at one point they had the 100th anniversary. You can get them in hardcover, softcover. But I was flipping through the book one day, and I saw that they had an article, and I stole these from Ham Radio Secrets because I just moved. My printer scanner is packed away, and I couldn't just scan the little page. But they talked about a quarter wavelength sloper off of a 50-foot tower. Now, I should have grabbed a photo of the RMHAM field day, but we have a number of these old news vans with 50-foot pneumatic masts. We add a little bit on the top and put a tribander up there. And 50-foot antenna. I'm in the middle of a field. How do I put up a dipole? I don't have anything to connect the ends to, so it can't be wire. And I want to be on 80 meters, and we all know what's the length of a half-wave dipole for 80 meters from our, probably the general class test, 468 divided by the frequency in megahertz. So 468 divided by approximately 4 or 3.5. That's 128 feet? That's what was up on that beam. That's why I say we're never going to build something that big. So we tend to do an inverted V. And Chris talked about the impedances and the match, whereas an antenna that might be 50 ohms this way, as I start to bring them down, or maybe it's not 50 ohms, the impedance changes as I bring the antenna closer to the ground. If you've built, let me see how good these guys are. Did you bring a quarter wave ground plane? I should have brought one. I have a nice 900 meg one that's tiny. But when you build a quarter wave ground plane, you're building the vertical element of the quarter wave with radials. They'll tell you to bring them down to about 45 degrees because it's closer to a 50 ohm match. So I wanted something that I could connect to either a post or just keep this thing going out because we got a lot of space. And I said, well, I could do a half wave, but that's a pretty big tower to get this at a 45-degree angle. But I can go to a quarter wave where we just put our radiating element counterpoise, and the coax can even be your counterpoise, but you've got to decouple at about a quarter wavelength down. Otherwise, you're going to have a lot of RF in the shack. Remember that the shack is down here on that antenna with the counterpoise. So I thought this would be a great antenna for field day. All I need is, as I say, if I extend this out, a tent stake, and I'll put rope here that's insulating. And the antenna book says to get it to tune properly, it's best to put a capacitive hat above it. I've got a tribander up there. It's all electrically connected. It's like this Yagi. The elements are bonded to the boom and these big, that's a capacitive hat. So we're going to try building one of these for field day. You could even, I'm just looking for where on my slides. You could even put this off the peak of your house in one direction, little wire, and get on HF. The other piece is, I'm going to build one of these at my house called an inverted L. Your shield of your coax is going down to some form of ground plane. You come out and either have a tuner here or not. I'm going to place a small antenna tuner, and I think Willem is going to talk about non-resonant antennas. I'm a sarcastic guy, but I'm also a resonant kind of guy. So you've got to embrace my sarcasm. I am a member of the National Sarcasm Society. Like, we need your support. But I'm going to come out of the ground, go up to the peak of my roof, and go out really long to a tree. I don't know if I'm going to set this up to be a resonant length or a non-resonant, but with the tuner, I can tune most any antenna. Very simple antenna. I'll probably just temporarily lay these down in the grass, let the grass grow over. Maybe I'll get some of those landscape cloth hairpins to keep it down so I can just run the mower over the top of the wire and go. But not a good field day antenna because we don't have any trees to anchor it to. But if we did, I'd maybe try that. So instead, we're going to go with the inverted L. So, okay. So that was some HF and tribe. And by the way, if you've got, don't make me talk the whole time. If you've dealt with some of these, tell us, or if they've worked or not worked. And those of you online, I think the lines are open. All they have to do is unmute and come on in. Or you can put it in the chat. Mark will read it to us. But feel free to open your microphone and chat with us. So, I don't know if this is a bad joke. Someone gave me a Cushcraft tribander one day. I didn't want to look a gift horse in the mouth, but you may get one of these. There's a little picture of the Cushcraft, which Cushcraft is an old company. I want to say it was founded in the 1970s. They were bought out 10 years ago by MFJ. MFJ is now out of business, but there's still a lot of these kicking around. They're pretty good antennas all in all. And RMHAM had donated two of these to us, maybe three. And I bought a new one. I doubled down. Maybe I thought I was in Vegas. When these were closing out, I bought a brand new one from MFJ because I learned what we learned. So you go through this thing, You set up your antenna elements at the exact lengths according to this very easy to understand chart. And you can set yourself for phones, center of the band, CW on the 3 bands, and you just get the proper trap. There's TAs, TBs, and TCs, and make sure that you pick your band and get all these spacings correct. Notice the little arrows. There's a little arrow on the trap. You want the arrows facing in. What could go wrong? What could go wrong? I set my spacings. It took me half an hour of studying this chart to say, what's the spacing? Oh, it's on the next page and it's over here. But the elements are bonded with metal clamps above the boom, so I'm assuming the engineer is compensated for that. It needs a little balun. You can either run this coax, or I tried one of these DX Engineering. They're a little newer on the block compared to ham radio outlet and the former AES, but DX Engineering, they know what they're doing. They're very competent, and I've been buying from them more and more, but ham radio outlet's a great source also. But I bought one of these little baluns, and Willem will get into this a little later, to replace this coax balun. And I'm finding this works a little better. So we put this thing together, and we had a brand new one at field day, and I think Mark and Glenn kind of cringed a little bit because we went to put it together. This was not 24, field day 2023. It didn't work. So it partially worked. So what we found on that one, these are the actual, I call them 40-meter traps, but it's really a 20-meter trap that stops 20 meters and lets 40 meters pass. And you put this on your driven element only. So what you have is 3 elements on 20, 15, and 10 meters, and a single rotatable dipole on 40. But this the one antenna kind of resonated on 10, but it was in the wrong part of the band. Didn't like 15 at all. 20 was, it was just weird, and 40 meters. So we spent a lot of time, took a lot of measurements, and we finally started taking these apart. We color-coded them and labeled them. We tried to line them up here, but as you can see, there's a difference in here to here. Some of these had 60 turns, some of these had 70 turns, some of these were like 12 inches long. You notice this little screw hole. Well, you put this metal cap over it. What this makes is a series inductance with a capacitance. The capacitor attaches there and here, and online you can't really see, I apologize, but and this end is insulated to form a capacitor. Well, if you put this thing in different places, you have different capacitances, and you have different lengths of inductance. No wonder they didn't work. So we had 6 of these. We finally found, we've rebuilt, and I think we have 8 of these. I think we have 4 of these 40-meter kits. Because if I'm going to build this from scratch, that's a lot of work. I guess we could get somebody to 3D print this, but one of my mentors in the world said, buy what you can afford, build what you can't. We can afford to buy some of these and have some spares. So we now have 2 40-meter kits that work, and we're going to rebuild these 4, so we have some more for field day. But somebody may offer you one of these antennas at a great price, but beware, but you put a little bit of work into it if it's not working. The other thing is we found this enameled wire. They didn't take the enamel off before they put the screw down in some cases. The little plastic caps that go over this end and this end will break and become brittle over time. And then insects get in there, and Chris was talking about dielectrics. they're not a good. So what we do is we actually go on that little company with the blue trucks with the smile on it. They can deliver, you can buy marine heat shrink that has the glue inside and it's thick. And we just cut a piece of heat shrink and put it over here. And that's going to last longer than the rest of the antenna probably. So good antenna if somebody gives you one to get on with a basic, small backyard Yagi. Cushcraft also uses the same design for their verticals. And John and Willem have some of their verticals. And that same year at Field Day, so I guess this would have been 2023, John was pulling his hair out. And he handed it off to Willem to say, fix this. I'm sure it was brand new, and I'm sure Willem remembers it well, and he put, and you were pulling it out, and you spent, I know, a number of hours up there trying to figure this out. This is the man that has a PhD in mathematics and computer science, I guess. He was practically modeling this thing in his head, and we just couldn't get it. And he asked me, and I looked at it. Do you know what we found? Remember I said, pay attention to the arrows? Well, apparently the Einstein that built this thing put the sticker on backwards. How do you figure that out? So I put up here a link. I just stumbled across this. So I don't know WB4IUY, but he has a link about hooking a grid dip meter. And later I found, we tried hooking a grid dip meter to it. Anybody here remember the old ICO 721 grid dip meter? I found one used with all the coils and mint shape, and I bought that. We just pretty much gave one away at the Swap Fest, a Heath kit. Mint shape, I think we struggled to get 20 bucks for it. Whoever got that got a steal. But IUI used a lot more turns to couple to, he put like 6 some turns versus my 1.5 turns. And I think that was my problem, that I couldn't get it to resonate. And we're definitely going to read through that and try this, because we still have at least 4 of these to fix, plus my brand new tri-bander, which I believe it was a COVID produced. And Bubba down there in Mississippi just wasn't getting it right. This was the, well, these, yes, most of these were manufactured by MFJ that we were retrofitting to tri-banders, half of them built by Cushcraft, half of them built by MFJ. But the point is, this is a practical Tapas. You may encounter this. Okay, and where am I on time? Okay, so is bigger better? So these are actually antennas that I have personally installed. This is our VHF contest group that I used to participate with in Western Massachusetts. The group was based out of Troy, New York. And we used to put up in the left photo 11 element 6-meter Yagis on 45-foot booms. That's a permanent tower that's there, an 88-foot monopole. And we would put those up. You had to put the top one on. You had to literally bolt another bracket on and physically sit on the top of the tower to drop this thing on. And I did that, I don't know, 6 times until we decided this is too much work. And also, it didn't work well all the time. This 2-meter antenna, I built that many, many times. 12-element KLM Yagis, 2 H-frames. Remember we said 1 Yagi to 2 Yagis, 3 dB, 4 Yagis, another 3 dB, 8 Yagis, another 3 dB. This whole tower was put up for the weekend. It's 50 feet, around 25. That's a what are they? Thrust bearing on the top. the entire tower rotates. So we could aim all 8 antennas in one direction. That was a pretty good antenna, but it was a pain to put up. It took 2 men all day to build that thing. 8 220 antennas, 16 432 antennas. They worked great if I was aimed over at Tristan and I'd hear him really loud, and you guys, I wouldn't hear. It was too focused. So we said, let's get rid of this. And we went to the 6 element. And we actually used to use 4 of them on the tower, so 4 stacked. The upper 2 could be rotated anywhere, and the lower 2, we had about 300 degrees of rotation. Worked a little better. This was a design that a gentleman by the name of John Kenny, W1RR, did. And my friend Fred took that design and modified it, optimized it for the way we were mounting the elements and all the pieces. But this antenna not only had a front to back of about 35 dB, the front to rear, the entire back hemisphere of the antenna was at least 25 to 30 dB. Those lobes that Chris showed on his were all down on the back. Why would you want to do that? I'm not aiming this at the moon, but I had really loud stations behind me in New England that I didn't want to be sitting in their prop wash. When I was listening over there, I didn't want to hear the guy over here 3 kilohertz away on 6 meters. So they worked a little better, but we realized there were holes in our grid map that we weren't working people. So, Tapas, does anybody have a tomato allergy in here? Okay, you're all safe. So Fred said, let's go with some smaller antennas. And he came up with the tomato stake. He took all of that former book knowledge that John Kenny did, W1RR, that Jim Lawson, W2PV, the guy with the big Bertha, and you can still buy Jim's book at the ARL bookstore about optimizing Yagi antennas. Lots of formulas, and I make it through about half the book. But Fred said, well, what if I built wooden boomed, 3-element Yagis? He went to Amazon and got hollow tomato stakes. And for the elements, he's got number 12 wire. He developed a feed, but what he really did was modified the feed and the phasing to reduce energy off the back. And we put 2 of these up on a little piece, and I think I have a photo of it actually deployed on the mountain. So we started playing with, we still put up the big stack, we call it our primary stack, and it's up on the hill and right on the peak of the mountain. And that's fully rotatable, and we can work anywhere. And if, you know, this is the highest mountain in Massachusetts. I know it's 3,491 feet above sea level. The bottom of our wells are higher up. But in Massachusetts, that's pretty darn high. From this stack, we can, if the band is right with the double hop, we can work California, we can work Europe on CW sideband on this big antenna. Then we came down and put an 8-foot piece of tower with 3 guy wires and 2 tomato stakes. But we placed it where it was on the mountain that we had an upward angle. But what's coming off this antenna is also a downward radiation because it's a big donut, right? You're shooting half your power down into the ground. And if you have the right foreground, that will bounce back up and hit the ionosphere at a different point, which will then bend down and work a different part of the country. And so we tried this up here. This was in June. This was September after we modified it because I think it's kind of a funny story. The environmentalists came up and the park rangers and said, you've got a guy wire over this little path. If we had to get an ambulance through there, we'd hit your guy wire. You got to take your antenna down. So how did we modify it? We took the piece of tower, we shoved another piece of tower in, and we only have 2 guy wires with a stiff support. And we looked at the ranger and said, okay, problem solved, no more guy wire over the path. And she was like, I really wanted you to take the antenna down. but you did what I asked you to do, so I can't force you to take it down. So this little tiny antenna, and then we said, well, it works so well, and this was pointed southwest, what we call the corridor. From New England, we aim down this corridor and we get New York City, Philadelphia, DC, and points beyond, and that's where the population center is. We went over about 600 feet away, and we put another one. We only had one available at the time. We're going to put multiples there next year, and that's aimed to the west-northwest. Again, good foreground, and it's considerable distance from this big one, so we can actually transmit and call CQ up here, potentially aiming to, sideband, so we're at 50.1, while we're listening on FT8. And then as soon as they're done transmitting, we can transmit, because you can only have one transmitter at a time. We're far enough apart, and with this front to back, we can do that. But you're probably not going to do that at your house. But you could put this in your backyard. And to prove to you how well they work, a little bit of bragging. This is our 6-meter station up there, and there I am on the right, and Fred, K2TR, on the left. This is the PSK reporter. Some of you guys have used that. I set this up to tell me who has heard my station in the last 15 minutes. And every one of these was being heard using the 2 tomato stakes 10 feet off the ground. 2 tomatoes, so 2 3-element Yagis, 6 elements total. This antenna right here. This is where we were heard on that antenna. You don't need a lot. You can build a tomato stake, because you're probably in Amazon Prime, so you got to factor in the shipping and the tomato stakes. This is a $20 antenna. But you can work a lot. But we also kind of said, well, we think, just due to the weather, the ionospheric propagation predictions, we're going to see South America. So we took an antenna, pointed it south, and sure enough, people started coming back. So we were working Brazil, Chile, Peru. But you need a little bigger antenna for that, but you can do a lot. You could do a lot with a Moxon. So if you've got an HF plus 6 meter, I'm going to skip this one because we're going late. So you can do a lot and get on the air. We've done the inverted L. I'll go very briefly through this. Again, I stole this from my good friend John, W0ZQ. He actually modeled a simple 6-meter dipole, and he put it at 40 feet. He did a 2-element, a Moxon, a 3-element. But you'll see here from, now these are horizontally polarized antennas. So he's got an E-plane plot and an H-plane. The pattern of a simple 3-element, you wouldn't expect a ton of gain, but you can see, I think this is the dipole is in blue, because that's very symmetric, isn't it? The 3-element, there's a little less to the back than to the front. And here is your vertical pattern. The main lobe of this antenna is not right at the horizon. It's slightly up. But if, in this case, it's 6 meters, or if you're trying to work your buddy on ground wave, this is not the best antenna, because your lobe is going to be above them. But if you're trying to work FT8, a lot of people, who plays with FT8 in here? Okay. And online, I can see your hands going up, thank you. So you've got a main lobe coming up, I can't read how many degrees above the horizon. And then you've got other side lobes. Remember I said that big antenna on Mount Greylock that we just looked at, the 6-meter? Didn't work well. Any station that I would have needed energy to come through at this angle to hit the ionosphere and come back down. And in our case with the geometry, that meant we didn't have any significant energy. About 700, we had this ring 700 miles out we couldn't talk to. because our energy wasn't in the right place. Now, this is only a 3-element Yagi. If we go a little bit longer, I'm not going to really compress as much in the vertical plane. I will a little bit, but it's really the horizontal, the azimuthal that Chris talked about. But if I add 2 of these antennas, just like Chris's balloon, I add more antennas, horizontally polarized antennas vertically, and I scrunch this down. Thank you for bringing this prop, Chris. I'm gonna steal this. Do you also do like balloon animals at parties? You just round animals. I'm just gonna say you've got skills, but that's what stacking antennas does. I don't have any more power. I'm just shaping the pattern. And if I take a whole bunch of horizontally polarized Yagis and I go from 1 to 4, like we did in the pictures, what I've done is taken that vertical beam width and gone, scrunched it down. Then I add more elements and we bring it in. So by adding that 2-meter antenna that was 8, with the 4 antennas stacked, I brought it down here. And then with the 2 wide, I brought it in a little bit. So I had this column of radiation going out. So if I was shooting to an aurora that was slightly elevated, it was still in my beam width. If I was trying to work down direct ground wave versus a tropo inversion on 2 meters, you need the right polarization, the right illumination of whatever you're bouncing off of. And if you don't have it, you're not going to work them. If you do have it, even a small antenna with the energy in the right place, you're going to go places. So I don't know how I'm doing on time. I'm probably ready to turn over to Willem. It's coffee time. And this was my coffee that I got on a business trip, and it was a heart, and I stirred it up. And I think that looks like a Boston Terrier or a Bulldog. But, and everybody knows Rocky Mountain Ham's motto, DFIU, don't F it up. But the VHF group that I'm with, the Mount Greylock Expeditionary Force, W2SZ, our motto is don't start vast projects with half-vast ideas. So hopefully this hasn't been half-vast. And Willem is going to continue to, how do we make antennas work? We started with some theory. I tried to give you a little bit of practical, and then we're zooming into, you can build any of these, and then hopefully you can take the tricks we've taught you here and make some contacts with these. And if you don't make contacts, you're going to go, I think I know why they gave me some of the primers here to be able to use this. But, you know, I've been fortunate to have a lot of really great mentors or Elmers, one of which was Fred there. And he said to me, don't ever buy an antenna that you can build. They're not that expensive. You're going to build it. It's probably not going to work. Come talk to me and I'll tell you why I think it didn't work so we can change it and keep building. And a lot of the antennas that he built didn't work the first time. It took a couple of iterations, but when we were done, boy, did they work. So any questions while I'm getting Willem's presentation ready here?